My name is Tony Galata. I'm the Director of Technology here at Akana. I manage a couple of our products here, namely the API Gateway and the Envision product. And in this session, we will talk about analytics, why traditional analytics don't give us the proper insight into our API programs. I'll talk about the differences between operational and business analytics. We'll introduce the Akana Envision product, and I'll do a brief demo. So let's first set the stage with a common API example. So in this example, we have a company, a retail company that started off with some brick and mortar stores with some point of sale terminals. Those terminals all interacted with a back-end business database. In this case, we have them talking through a SOAP web service. And then at some point, the company decided to expand by having an online website for shopping to expand their business beyond where their stores could reach. And instead of using this SOAP web service, they went with a different API, a JSON RESTful API that's still interacting with the same back-end business database for all their orders, sales, inventory, and whatnot. And then finally, as a lot of businesses are doing these days, they thought they would try to expand even further by enabling partners to sell their goods and services through using the same API that they are using for their website, but now enabling it to be used by partner applications, possibly mobile applications. So using this as a context, we'll start talking about analytics themselves. And if we talk about traditional business analytics, those are traditionally focused specifically on the business, marketing, or measuring the effects of, say, advertising. The data is extracted from the back-end databases themselves. These are very good at understanding the core business. They understand what they're trying to sell, the items, pricing, things like that. But they can lack a few things, such as context about the clients themselves to compare. So in our example, are they collecting how much is being sold by different applications at all, instead of the website, instead of their brick and mortar stores, how much is coming from other avenues. It will also usually lack operational information. So it won't have information about when there was outages from APIs or when there were performance issues of APIs. So it may not be very easily explainable why on certain days or certain hours of the day that there are problems with making sales, that a business is suffering and not knowing maybe why that is the case. And then we really can't truly identify a positive or negative impact of the introduction of APIs to the business. Now, with traditional operational analytics, there we are usually focusing on measuring the availability and the performance of the APIs alone. The data is typically extracted from messaging gateways. That information can be fed back into the gateway and help us with things like throttling clients, trying to avoid denial of service. They truly have good value. And they can also help us to measure the adoption of APIs by looking at the client usage itself. This is at a high level. It doesn't provide any insight into what those APIs are really doing. And in our example here, where we have multiple APIs, we have a SOAP-based API, we have a REST-based API, all talking to the same back-end system, all serving the same business function. If we are just focusing on operations and looking at each API individually, we really aren't going to be able to get a nice broad business view of what's going on. And once again, we cannot identify easily the business impact of the APIs and the introduction of those APIs. All right. So what if we could bring these two together? Actually combine the traditional business analytics with operational analytics. Then we might be able to get some more insight into things like how the introduction, adoption, the operations of the APIs themselves are affecting the business. We can look for deeper correlations between how each different avenue of sales, such as apps, websites, brick and mortar stores, how they might be more or less effective in, for example, selling particular goods and services. Some things may be more effectively done from an app than others. You may not be selling as many of certain types of goods with apps. They may still be traditionally best served by offering them through your brick and mortar store, where there may be other things that seem to be much better suited for online shopping. We can also try to better identify the business areas that may be better or worse suited to the introduction of APIs. So as I was saying, if something is not very well, has not traditionally been selling well through apps and APIs, then maybe we shouldn't be focusing so much in the future on expanding our APIs in that area. Maybe we should still focus on things that we are seeing the true business return on investment. And that's where we can focus our API expansion and our enabling of our partner apps. And now we can also then truly quantify the costs, the business costs associated with when we have API instability. When API outages occur, we can now correlate that with why we see the business is having struggles at that time. Or if there are performance issues, we can now see that this is why we are seeing these drops in our business. So let's just introduce Envision. Envision is a pure analytics engine. It's highly scalable, and it does this through offloading all the analytic aggregation and computation to a farm of NoSQL servers. It provides a rich charting and mapping library for building highly functional dashboards, visual dashboards into the data you're collecting. It is built with an extensive API library so that it can be easily integrated with other systems in your environment. Now, Envision itself does not have any built-in domain knowledge. It doesn't understand the retail world, and it actually does not even have any sort of hard-coded logic for operations, even though that is one of our core businesses. Instead, it is purely driven by metadata, and in the case of operations, the metadata is constructed by our API gateway product. But it's this metadata that is used by Envision that will tell Envision on how to aggregate and combine this data to come up with something meaningful for the end user. Now, the data for APIs, that is extracted by our API gateway product and is done through a connector. So let's have a kind of visual picture on how Envision interacts with different things in the environment. So as I discussed before, Envision itself sits on top of a farm of NoSQL servers. This allows the ability to do sharding as well as replication so that we can try to scale horizontally. The Envision product has a web-based interface built on its API. So that people can interact through a browser. This API can also be used so that you can leverage other reporting tools that you may already have. So you can have these reporting tools extract the data from Envision and then use their constructs to publish the data to a different audience. As I was talking about connectors, the Akana products themselves will have their own connectors that know how to populate the Envision product with relevant information, the API gateway providing you the API runtime operations, as well as the payload information that allows you to do the business analytics. And then If you have existing business systems that you would like to plug into Envision, this API we have makes it easy for you to build your own connector so that that information can be extracted and then injected into Envision framework. So just briefly, we'll talk about connectors. These connectors are product specific, or if you're building your own, they're for your own business specific purpose. They understand the product domain. They extract business raw measurements from each of the products and inject them into Envision according to the metadata that describes it. We call that metadata a data set. In the case of the API gateway, what it will do is it will create metadata or data sets that will reside in the Envision product. They will have policies that know how to extract the operational metrics and inject them into the Envision product. And it also has the ability for you to define policies that will extract business-specific information. So in our case of the retail industry, it would be able to go and look at transactional information and extract things like the store that the purchase was made from, what the item was that was being purchased, the price of that item, on and on. Anything that might be specific to the business that is important for you to analyze that can be extracted from the messages that come through the API gateway. The API gateway, like I said, provides these policies for you to define exactly how that information exists in the payloads and then how to extract it and then inject it into Envision using your own data sets. Connectors that come with our products will install all these data sets. We'll install some charts. We'll install dashboards, a lot of out-of-the-box visualization tools so that when you install an Akana product with Envision, you will not have an empty slate. You will have some valuable information as soon as you install and run the product. And each of these connectors are packaged with each of our products. Okay, so I have a couple more slides that have pictures of Envision, but instead of doing that, instead we will go straight to the demo. This is the web interface for Envision. When I first log in, I get a set of dashboards. Now, the dashboards are different for each user. Each user controls what dashboards they want. Users can help by configuring dashboards for you, or you can configure your own, but you're always free to pick which dashboards you want to have viewable when you first log in. In this case, we're looking at sales. We're looking at kind of a true business view of the example we had earlier of the retailer that had the store's website and the apps. And this dashboard, this view, we're looking at breaking things down by those three channels. So in this first page here, you can see that we're looking at the amount of sales that each of them are making. It starts off, the stores themselves actually are selling the most, as you would expect. But in this graph, you can see how the apps start to slowly catch up and then obviously overtake store sales over time. And our website just kind of moves slowly but stays respectably behind the stores. Now, each of these charts that you see on a dashboard are not just static content. Depending on how you create your charts, these things can be functional. In this case, we can click on time, and we can actually drill down into this information at a more granular level. So now we're looking at actual weekly data instead of just that was the previous page was for the year by month. On the right, we have a different chart, a pie chart that shows the breakdown and percentage of sales done by made by each of the different channels. Now, as I said, these charts can be functional, and that's another thing that you can do depending on how you create your charts is you can create these filters that the charts are using to draw their data. You can change these filters on the fly, In this case, we were looking at, as of today, the previous year percentage, and now we will look at the year from August 31st. We'll see that this is redrawn with a different set of data. So the charts that we construct dashboards with are visual. They can be static, but they can also be functional. On this page, we're also looking at things like promotions. So we can look at how effective are certain promotions with respect to an app versus a store versus a website, which ones are, picture doesn't show it as well, but there could be certain promotions that are very well received using mobile than they are at stores. Different dashboard related to what we're doing in this example. In this dashboard, we're looking at apps in particular, but now we're introducing the concept of the operations. So on this chart here, we can see we're looking at actual sales in terms of a dollar amount. We can see that at two different spots, the amount of sales that we were trying to make went down dramatically. Now we're overlaying this chart with a chart from the operations, API operations analytics that shows us errors. And we can see here that we had two spikes in errors right about the same time that we actually had a drop in our sales. So that kind of helps us to see that there is an actual effect that we had on the when we had our failures, and we can actually even quantify, approximately how much money we lost when this happened. In a similar view down here on the bottom right, we took the same sort of concept, but this is now units sold, and now we're looking at response times. We're looking at performance, and we can see that our average response time spiked up in two different times, and that also correlated to a drop in the amount of units that we could sell because the APIs were just not keeping up. It may have resulted in errors as we see up here. But either way, we can try to see together an example of where you can take some of the operational information and combine it with the business information, all coming from the same set of messages from the same API gateway. Okay, so with that, let's kind of just look at how do you build a dashboard, how do you use these analytics in Envision. So we start off with data sets. Now, data set is that metadata that we were talking about earlier. If you look at an operational data set, you see things that you might expect. Things about operations and services, request status, the timestamp, an HTTP verb, a URL, the agent header, status codes. These are all we call dimensions. Now, a dimension is a way to organize your metrics. Think of it as what you would put in the where clause of a SQL query. So if I want to grab certain measurements, I want to do it per operation or per service, or I want to get them for every time I got a request status of a certain time, a GET request versus a POST request. These are all things I can build queries by, filters with. The metrics, these are the measurements. These are the things that we're trying to measure, what we're trying to quantify. So in this case, with the operational set, you see also traditional things like the count of messages, the size of messages, the error counts, the response times. These are common things that you might see in an operational data set. And then finally, a data set is also defined by its granularity and how it calculates and aggregates the data. So if you have, you want to keep this information, you want to collect it for minutes or days or hours or years at a time, that's what you would do here. You want to have the granularities chosen that make the most sense for the way you want to chart things. So if you want to chart your data per month, then you would probably want to make sure you've checked off the month button here. You also get to choose how long you want the data to actually exist in the data store. So we will do cleaning for you based on your directives here. One thing I did not touch on about the metrics, well, we'll go to that in a second. Let's look at one more data set. Okay, so in this data set, we have something that's a little bit more business-oriented. So for the same API, in this case, as you can see, our retail, we're selling shoes. So our retailer is selling shoes, and the things that we want to collect about from the business aspect of things are: is it being sold by an app? Is it being sold by a store? And the way we would collect that doesn't actually have to be something in the payload of the API itself. It can be something that we derive from reading headers. The payload of your messages can still be very simply dealing with transactions. The API gateway can look at, say, HTTP headers, if this is the RESTful API, and it can actually extract, okay, this was a partner app, and this is the actual app ID, by extracting some authentication information from that request. We can collect things that are very business-oriented, like the promotion that might have been used to sell the item, the style of shoe that was being sold, and this allows us to kind of build our charts and base our filters on business information. The metrics, the things that we're collecting, in this case, we're really focusing on number of units that we're selling and the amount of money that we're bringing in, so dollar figures. So you can see subtotals, transaction totals, quantities. These are things that we want to measure from the business side of things. Each metric has a different type, and they have different aggregations that you can perform. So do you want them to be summed? Do you want averages? Do you want the minimums? Do you want the maximum values? These different types of calculations. You put that into your metadata, into your data set, and the Envision product will actually aggregate the data and perform those calculations for you. All right, now once we have the data set, and what we're showing here, which is our API gateway, we'll have policies constructed that will actually then collect the information from the messages and populate these data sets. Then we can build charts. We want to visualize this information. So if we look at one of the charts that we already saw on a dashboard, we'll look at how the errors affected our app sales. When you build a chart, two different areas. Left-hand side is how you configure your chart. The right-hand side gives you a preview. This preview is a live preview. It is exactly what you would see on a dashboard. It actually pulls data from the data store, so this is getting live information. So you know exactly if you got it right before you finish. When we build a chart, we start off with what the data set is. We pick a granularity of which we want the data points to be. And then we can pick those dimensions. What do we want to group by? In this particular case, I want to get things based on a per app basis. We can define filters. If we put a checkbox on this filter, then it shows up on this page's drop down like I showed earlier, so that users can change it, make it a functional dashboard. I don't have to put that checkbox on there, so I can make that filter static if I'd like. Then I define what type of chart I want to use. We support several different types of charts and customizations of those charts. In this case, we're picking a spline. And then we can also have drill down. We'll talk about that in a second. And we can make these zoomable. So we can actually expand it and view it closer for people who have bad eyesight like me. Now when you define our X and our Y, each chart is a little bit different. Pie chart, for example, doesn't have an X-axis. But in this case, we have an X-axis. We pick what do we want that axis value to be. In this case, we want it to be the transaction date. Give it a title. We can have it formatted in different ways. And then we define our data series, which we can have more than one data series for this chart. In this case, I have one data series, and it is based on the value I want to plot. And I want to plot my transaction subtotal. This is not a dimension, but a metric in my data set. How do I want to aggregate that over time? I would like to take the sum of all the transactions, and I would like to add them up for each period of time. And I give it a label and a title. Now that is just one single app. That's the spline. Now we see that we have a couple of bars here. That is from a second chart. We can overlay charts on top of each other, kind of build an aggregator or a compound chart. And that's what we've done here by adding another tab. In this example, though, we're not using the same data set. We could, but in this case, we're not. We're going to go and use the operational data set, and we're going to extract data from there. We're going to do it at the same granularity, though, of days, so this all makes sense. we're going to pick the service. In this case, we're using that RESTful service. That's what the apps use. We create some filters. We choose a different kind of chart, and this time we're going to use a standard column chart. X-axis, we're using, it's called timestamp in that data set, but it's the same concept of time that we need to use. And now we're going to graph error count and the sum of the errors over time. And that's what's going to give us this other overlaid set of charts on top. Now, we have plenty of options for how we do this stuff. This is an overlay. We could have chosen to do what we call a drill down. So I think we saw earlier I had one chart where I drilled down by time, and I went from a yearly view to a monthly view. That is achieved using the drill down pull down here. If I say drill down by x-axis, that's what it's going to do. It's going to drill down based on time, and it's going to pick whatever this granular unit of measure is here, and it will actually go to the next lower level. So in this case, we were doing days, then it would probably go to hours if I use that drill down method. If I use series, if I use the data series, then what will happen is it will not show the second call. It will not show an overlay. I should go to the right chart here. It will not show the columns at the same time. Instead, it will require me to click on something on the chart on one of these lines, and then it would actually expand and show the bars in a separate chart. So we have the choice of navigating between charts or overlaying charts on top of each other. Okay. So now that we have charts built, the next step is to build our dashboard. So to build a dashboard, we click on Configure. Let's create a brand new dashboard. And let's add some charts to it. So I'm going to pick a couple of the charts that we already have seen. Go back. I'm going to kind of put them in a certain default size and location, which we're probably not going to like, so let's change that around. Okay, so we can see everything is done the way we like. At this point, we can now save. So now if we want to actually see it up in the dashboard when we log in, we want to make it a favorite, and that tells us this dashboard will now show up when I log in my pull down. So a list of these are my favorites. What I see here are my favorites. You can see my live dashboard is functional and ready to go. Now, one thing I did not touch on with all of these items that we have is we have what we call sharing options. So when I create a data set, a chart, or a dashboard, I create my own. These are mine. I am the author. I am the originator. I can share these. So I can actually, when I create one of these, I can click on a button that says I want to share this with everybody. And when they are shared, then everybody will see them in their shared area. And obviously I can make things favorites when the list gets very long. I can actually make something in my favorite and I'll get a simpler view. And of course we can filter and search for things when things get really big. But when things are our favorites or they're ours or even shared, then I can actually use them. If I didn't make something shared, if I made this particular data set private, it would not show up for anybody else to use. So we're encouraging people to kind of build things collaboratively. We also then can enable the analytics developer, if you will, to create dashboards and charts that may be for his boss, so the managers don't actually have to get their hands dirty. They just can log into their system and see dashboards and views that were constructed for them. So a couple different ways and roles that can be developed for that. So I think that is all I was going to show today. There are other things, but I kind of didn't want to go too long on time. Sometimes I can go quite long on the demo. So I think that's it at this time. So we want to open it up for any questions that anybody may have.
Okay, there's some questions coming into the Q&A box. We invite you to ask Tony anything that you have on your mind. Tony, did you see the first question teed up there? For Akana customers with an on-premises implementation, is the MongoDB data layer also on-premises?
Yeah. The way typically MongoDB, yeah, it would be, if you have an on-premise deployment, you would also want your MongoDB instances to be on-premise. This is where you're really going to find, you know, the most computation going on. It's not going to be in the Envision process itself. The Envision process more or less directs, you know, the servers what to do. And so those you're going to build, you know, the farm of those the way you need. You may distribute them if you have multiple data centers of your own. You would probably shard these things to the different data centers to live closer to, say, the API gateways that are collecting the data. And then what we would recommend would be doing sharding by data center as well as replication. It's a very flexible ability that MongoDB has for how you direct your queries. So you can build highly efficient queries against you know, replicated shards and have highly efficient writes by having these master shards with your API gateways, and I think that's going to provide your best deployment model. I guess I can, oh, there's another question. I can just move through these, I guess.
Yeah, go ahead.
How are you integrating and correlating the sales data with the API operational data? Well, there are a couple things that I didn't show it, and I would have liked to have done it. We're in our beta right now of our next version of our API Gateway product, and in that beta, we're going to, or in that, when we release that product, which will be soon, you'll see the what we call our connector, right? And so I touched on it earlier, and I'd like to show it, but I didn't think I'd have enough time, and maybe I would have if I'd have planned properly. But we have these policies. If you're familiar with that product, you can create called business metrics policies. And in these policies, you have the ability to define how you would extract information from messages and message payloads. You can extract information that you would get from the operational side of things. So you can extract you know, your response times. You can extract status codes, any header, you know, message sizes, any of the things that we collect with traditional operational metrics. You can collect along with anything that is more proprietary to you, more business focused to you, which may come from the payload, may come from headers, may come from path parameters, query parameters. You know, we kind of have this this policy that kind of gives you all that power for you to extract what you want. And then you can define your data set to combine all of that together. So you can have operational things mixed with business things in a single data set, and then from there you can then, you know, create queries, you know, charts and dashboards that query that data in different ways to kind of put it together. What I did here in my example was a little bit more simple, and that was I kept the two data sets completely separate. So that the API Gateway was collecting the operational metrics and storing them as it normally would in its own data set, and then have a business metrics policy that would extract the business data itself and put it in its own data set, and then just kind of put both data sets in two different charts overlaid on each other. So visually we're getting the correlation. We're not getting it at the data level, for example. What we also can do is we talked about having multiple APIs for the same business. So what we can do is we can take two different APIs, create two different policies, where those APIs, like it could be very different. We were talking about SOAP versus REST. So, getting the information from a SOAP message can look much different than getting the information from a RESTful JSON message. So in that example, we would have two different policies that know how to extract the information in each of those different formats, but they could populate the same data set. So we are going to get in one data set view, we are going to get all the information from as many APIs that feed that business, right? So, we don't want the people in Envision, the users of Envision, to be concerned with that so much. They should be concerned with the business. Now, of course, they understand, okay, we have APIs and all that, but they don't understand JSON. They don't understand headers. What they understand is what do they want to get out of it? What are they trying to measure? And then the developers in the API gateway, they bridge that gap by understanding messages, JSON, XML, and things of that nature, and populate the data sets. Hopefully that answered the question.
Okay, there's a bunch of other ones coming in, so take a look.
Yeah, let me make this a little bit bigger here. All API calls go through the gateway, so they are instrumented correct. Well, yes, but like I said, it is really up to you to define how you want to do that with the choice of policies. It's not, we don't just do something automatically for you. We give you the control. You say what you want to do and when you want to do it. Can you throttle calls to certain APIs? Well, we do that today with the operational metrics. We don't need Envision to do that. But one thing that we will be coming out with this plugin that will come out with the use of Envision is you would actually be able to, if you're familiar with our product, the service level enforcement policy, for example, that allows you to kind of restrict access when quality of service violations have been reached, certain thresholds have been crossed. You'll be able to also base those on more proprietary things, business-oriented things. So today, it's limited to the operational things that we typically do that are general to every API call, response times and things of that nature. But let's say you had custom headers or content, you could actually extract that with the business metrics policy and use that for feeding back into the service level enforcement policies and throttling messages that way as well. Can you discover existing APIs? That is not something that we do in this product. That is probably more of a question for the API gateway or community manager. And we have, we import RAML, Swagger, Waddle, WSDL, as well as have wizards for you to define your URLs. But we do not today have something that we will point at a server and we will go and extract all of the actual content of what a post would have in it and all that information. Next question, you had a combination of operational data and actual content from the API. For the latter, is a Swagger spec enough for your gateway to understand enough about the API to know what data to send through the connector? So that's enough for us to, yes, register an API into our gateway. But if you're trying to try to determine out of the payload, out of the model in that case, what values do you want to graph? What is a dimension and what is a metric? That you will have to define through the policy because only you know and that content what is meaningful. So we will have the definition, but I don't necessarily know that property A is a measurable metric or a group dimension that you would care to query by. Okay, so I answered someone's question. Yes. Right. So does the collection policy and adapter add any latency to actual API calls? So just like we do with our current monitoring, what we try to do when we are collecting any data from an API call, we try to do that as out of band as possible. So what we'll do is we'll actually just kind of take a snapshot of the message as it goes through the API gateway and through different threads. We'll collect that information, batch it up, and kind of shove it into the MongoDB. So we do that in, like I said, in a separate thread. We try to avoid holding up any of the messaging that goes through the API. We've been pretty good about doing that so far. We've been doing it with our operational metrics for years. So this is really the same model. It's, like I said, the extraction itself, where you're pulling apart different elements out of the content, that is not done in the same thread. It's not. We try to avoid any sort of overhead because our number one goal beyond all this is to make sure that our customer's business is not affected by the introduction of us. So we try to be as transparent as possible, always, with everything we do. I believe that is the last question. Is there any other questions, anything I answered, but maybe I didn't answer to the best of my ability there?
Tony, would you like to share your email address if anybody wants to get in touch with you after the event?
Sure. So my email, I got it written down, but it's Tony, T-O-N-Y, .Gulotta, G-U-L-L-O-T-T-A, @ Akana.com.